Thank you everyone so much, and welcome to my talk when Porgs stream at Webpack and other stories. If you want to follow along the slides, I uploaded them on this URL, but I'll be tweeting them out later as well. All right, I want to start with a question. How many of you have like a Raspberry Pi, Arduino, or a microcontroller at home? All right, now keep your hand up if you ever actually used it. All right, cool. So there's still a large share of people who didn't. And so over the next 25 minutes, I need to disappoint you. I'm not going to dive into Webpack. I'll be talking about hardware hacking and hopefully excite you all to either use your existing hardware or end up on various websites ordering more hardware. Before we start, my name is Dominik. I work as a developer evangelist at Twilio. We're a cloud communications platform, meaning we have a bunch of APIs to solve different means of communication, like sending SMS. We have a booth downstairs if you want to learn more about that, and we have a raffle, so you can win something later. I think the drawing is at 3 p.m. I also heard there will be cupcakes. If there isn't, blame Jared, who's in the first row. So, but I also love writing JavaScript. I love writing it from anything from the browser, where I started doing front-end web development, to server-side JavaScript using Node. And I love writing CLIs using JavaScript. So a while ago, I thought, what about hardware? Can I use the same skills that I already have and the fact that I can run JavaScript everywhere else and run it on hardware? Because similar to a bunch of you, I gathered a bunch of hardware over time thinking like, oh yeah, I'm totally going to build something with this. And so end up with like 3 versions of Raspberry Pis and an Arduino and whatever was on Kickstarter. And I never really used them, at most for like a simple LED blinking demo, you know, like literally the thing that's on the Arduino website, where you just take that, plug in an LED, and then copy paste the code. And that's because, I don't know about you, but I think hardware hacking is a bit more intimidating than just hacking with software. And it's certainly not rocket science, but it certainly feels like it. One of the parts is like it requires preparation, right? Like for software hacking projects, everything is already either on your computer or in the cloud. So you, like for most things, you can just get started. But for hardware hacking, you often have to think about like, what do I want to do? What parts do I need to get? And then you need to buy those parts. Like, there's so many free software tiers, but you can't really go to a hardware provider and be like, so do you have a free tier for open source projects? They will probably not give you a bunch of things. And then one of the things that was intimidating for me was there's no git revert or command Z if you screw up, right? There's, like, I've been to hackathons where people were doing hardware hacks, and then halfway through the night, they burned through their components, and that was the end for them, because where do you get components at 2 a.m.? And so it can be a bit scary at first. But I found that as I started getting into this world more, it can be incredibly rewarding, because in times where we have things like hot module reloading and browser syncs and stuff like that, I feel like at least I've grown a bit numb to successes when I'm writing front-end projects, or like even back-end projects, because it's like I just write the code and I'm like, oh yeah, it already ran. Versus like in a hardware project where you're writing it and you're loading it onto the device and then you run it, and something in the real world happens. It's just so satisfying and so rewarding. One of the problems that I hit was whenever you look at like, how do I get started with hardware hacking? At one point it's like, oh yeah, you open the Arduino IDE and you write a weird mixture of C, C++. And I don't really remember most of the C and C++ I learned in university, and some people just never learned it. And so I think it can be even more intimidating on top of the fact that already I don't know a lot of the hardware things. Suddenly I also don't know the software things. And so I want to show you 3 ways that you can combine JavaScript and hardware over the next 20 minutes. So that you can use at least the skills that you already know to equip you on your journey into hardware. And the first way is through APIs and protocols. And what I mean by that is that we'll write some JavaScript that will be the core business logic, and then we'll interact via an API or a protocol with some C and C++ code on the hardware. But all that code really does is interact with the actual like hardware components. One way to do that is through dedicated APIs. So for example, there's the Particle Cloud API. And if you're not familiar with Particle, they're an IoT hardware manufacturer that focuses on device management and provides APIs so that you can control and trigger all of your deployed devices. So They have an API that allows you to just use curl or like your favorite programming language of choice to trigger an API, and then you just have to write a few lines of C or C++ code rather to expose the function that you want to be able to remotely trigger. And so you can do that part on the C++ code and then trigger it whenever you want to from your backend. But that's very specific to that vendor, and an option that is much more portable is Mqtt. So Mqtt is a lightweight machine-to-machine publish and subscribe messaging protocol. And so what that means is if we have, for example, a device and we want to tell the world that a button has been pressed on the device, basically it would send on what is called a topic, which is like a channel, a message like, hey, this button has been pressed. And then other devices like your computer, a server, can subscribe to the very same messaging broker and listen for certain topics. So for example, a topic about button presses. And the great thing about that is that you don't need to know the IP address of every single device. You need to know the address of your messaging broker, and that's about it. And therefore, it scales great to multiple devices. So if you want to have 20 devices that can tell you if a button is pressed, you can do that. If you want to listen with like 20 servers onto like whenever a button has been pressed, that's possible as well. And it's cross-platform and cross-language because it's ultimately just a protocol like HTTP. And so that would be an example of how you interact with it in JavaScript. You just load the Mqtt library, you connect to the broker, and then once it's connected, you can publish to a topic, you can subscribe to a topic, and it will trigger an event whenever the message is being triggered. In C++, that's basically the same. It's just a few more lines of code, and I'm not expecting you to read that. Instead, we can quickly walk through it, and you'll see it's pretty much the same code. You subscribe to topics. On setup, you basically connect to a specific server, and once the server is connected, you just trigger this loop function, which just means that you're like, because it's C++ and it doesn't really do event handling, you just keep on running this loop function instead. And then you have a callback, and there you're being informed about the topic and the payload, which is the content, and because we're in C++ land, we gotta know the size of the payload as well so we can deal with it. And then we just define the callback. And so what I ended up building with this is, I used to live in Berlin, and my flatmate there streamed on Twitch, and I wanted to know when he's actually online, so I'm not disturbing him. So I ended up building this live lamp, and the idea there was I had this microcontroller at the top is called an ESP8266, which costs around $3 online, so it's super cheap and affordable. And it had an LED matrix from a previous project. And so I connected them up, and really all this ESP8266 did was listen for a specific topic, and whenever there was an on or off event, it would turn the LED matrix on or off. So it would start pulsing like that. And why doesn't it? All right, it's not pulsing right now. Damn it. Videos. I think, yay, no, it should be. There we go. So it started pulsing like that. And so the way I then implemented all the Twitch-related business logic was I just had a server that would regularly ping the Twitch API and see, hey, is he online? Yes, no. And then if he went online, it would send a message. They went online or offline otherwise. And so the great thing about that is it's a very lightweight and intuitive way to communicate with devices, because most of you probably interact at one point with like a publish and subscribe mentality. And it moves all the heavy business logic off the devices, so you don't have to figure out how to do like computation and all of these things in C++. And it's programming language independent, so if you don't want to use this in JavaScript, you can use this in any programming language you want. You still have to write C++ code for the hardware though, so I ended up copy-pasting a bunch of code together from like 2 different projects that sort of did what I wanted. And you either need to deploy your own messaging broker, and there's a couple of open source solutions, or you need to pay a messaging broker. And so the next option is called tethered node bots. And basically the idea there is that we will write Node.js and it will directly interact with the hardware. And that's possible through a NPM module called serial port, which allows you to control devices that are connected via USB or serial ports using Node.js. And then on top of that, there's a library called Johnny5, and this is really focused on allowing you to talk to microcontrollers using Node.js and control hardware using a familiar syntax. And because it's running Node.js, you can leverage the entire NPM ecosystem. The problem is you have to be tethered to a host machine, and that means that not every microcontroller can run Node.js. And so if it can't run Node.js itself, you have to run it on something else, like your laptop, and then have a USB cable that controls it. But the code becomes really nice and beginner-friendly. So this is a Blink example that I literally just copy-pasted from the Arduino side. And basically what we end up doing is in Arduino, you always have a setup and a loop function. The setup function is being called once, and the loop function is being called over and over whenever you finish. And so in the loop function, what we do after we set up in the setup function that the pin is going to be an output pin, we just set it to high, sleep for a second, low, sleep for a second. In JavaScript, this looks like this. We import the Johnny5 library, we initialize a new board instance, and whenever the board initializes a ready event, meaning we're ready, we will create a new LED and we will call the blink method on it and give it an interval, in this case 500 milliseconds. But the real power comes with event-driven things, because JavaScript is inherently event-driven, and hardware is too. So instead of having to write a loop that checks if a button is being pressed and then turns on the LED and then checks if the button is still pressed and then turns it off, we can change that into event listeners. So we can create a button instance and then say we want to listen on press and then turn the LED on, and on release we want to turn the LED off. And so I don't know about you, but I think that's much more readable on what's actually happening. And this brings me to the Porg part of this talk. So recently I did a project that I called Porgs.js. And if you're not familiar with these little things, they're from the latest Star Wars movies, and they like screaming around. And so I had a conversation with a colleague who was like, why would you write Node.js code to control hardware if the hardware needs to stay connected to your laptop? And I'm like, well, you could write custom periphery. So the idea was I wanted to write a custom peripheral device that reacts on events on my computer. Or more specifically, I wanted to hack a Porg toy that screams at me whenever my build fails. And so, quick warning, you will see the insides of a toy Porg, so it should still be fine with the code of conduct. So what I ended up doing is I ordered this little fellow. He looks a bit grumpy, but I figured for the use case it's pretty appropriate. So this is just a average like toy that I ordered off Amazon. Nothing special except that it already had a useful functionality. If you press the belly, it will start yelling and wobbling around. And so what I ended up doing is I opened the screws and was like, all right, let's see how this actually works internally. And I started with the battery compartment because that was literally where the only available screws were. And from there, I could take off the fur, and I'm sorry for that. I must disappoint you. There's not much going on in the head. But eventually, I managed to get to the belly part of things where there was this microchip, and that's really all there is in this Porg to actually do things. And the bottom part, let's see if this, no, it's not working. So the bottom part is where the button was. And so my idea is that if you're not familiar with how a button works, it's basically a circuit that is interrupted, and whenever you press the button, the circuit is being closed. And so my idea is instead of using the button, I'll solder 2 cables at either end of the button. And so once I did that, and basically did a horrible job at soldering them. It's a bit dark, but that was not my proudest soldering. But I'm also not great at it, so I soldered them on, and then that allowed me to just connect those 2 cables, and it started yelling. And that was a good first step. And from there, I did some research, and I found out that there's this thing called an Opto Coupler, which is a little black thing on the what is called a breadboard. And I wired that up so that it would go to the Porg. So we would have an Arduino on the that would then connect to this, what is 4N35, that's the Opto Coupler, which allows you to basically simulate a switch in this case. And I added an LED because I think LEDs are the console log of hardware. You just throw them in at random points to see if it works. And so I wired that up, I closed it up, and started hacking around with the code. And at this point, I figured I like showing code rather than just keep having code on slides. So I brought my personal assistant here. And I'm sorry for the people in the back. I will have this at the Twilio booth later, so if you want to come by and look at it. But this is the little fellow. I don't have a name for him. Like, if you have a name suggestion, come by the Twilio booth or tweet at me. And so let me jump into the code. And just so that the folks that wanted to see some Webpack are not upset, I do have a random getting started from the Webpack website. And so I created a tool that is called Porgs.js, which you can install, and it exposes a porg command. And so what I can do with this is I can pipe in an arbitrary command in here that I want to execute. So I'm going to execute Webpack. Webpack, there we go. And right now my Webpack build works, so nothing is happening. But once I break the import here, for example, and trigger the same thing again, my build breaks, and hopefully, there we go. The little fellow yells at me. All right, so with that said, I could show you the entire library, but it's on GitHub, and you can check that out. But I still wanted to show you how easy it was to write the JavaScript for it. So what we're going to do is, all I need to pull in is two things from the Johnny 5 library. One is the board, and one is the pin. And then the other thing that I need to do is I need to create a board instance here. And because I'm using an Arduino, you can just use the default library. And then once we're ready and we're connected to the board, I'll call in callback here. And I'm going to make that async. I also need a quick helper here. I don't know why this is not exposed yet in Node. So I'm just going to create a quick sleep function here. So basically all that is going to do is call set timeout and then resolve that promise. Cool. So I have that. And so now what we need to do is we need to create a new pin instance. And I connected the pin on what is pin 4. So you can just look at the board and it tells you the number. So I'm on pin 4 with my Opto Coupler. And then what I need to do is I need to set the pin to high, meaning I put voltage on it, so there's power on it, and then I will wait for like a second, because we're simulating a press, right? And you're not instantly pressing for like a millisecond. So we're going to sleep for a second, and then we're going to set this back to low. And I'm going to save this, and now if we run this, he should be. All right, sometimes, because I'm really just simulating the same thing that the button, yeah, he likes talking. Let's see, we run it once more, now he might do more. There we go. So because we're just simulating the button press and belly press, and based on like different reactions, it does different things, because it's still a children's toy, right? Even though like we all seem very amused by it. All right, so let me jump back into the slides. But you can see that the actual code is not much different to the code we regularly write in JavaScript. And so for the pros and cons on like writing tethered nodebuds, the nice thing is with Johnny 5, you can write hardware-independent code, right? I'm using an Arduino right now, but Johnny 5 works for a variety of different pieces of hardware, so I could just swap that out very easily. You can use familiar tools. I used my normal code editor. I used NPM to install the things, and like overall just was able to use the entire like ecosystem that I'm used to. And it has a great website for beginners. If you're looking for like how do you control a relay, for example, or other pieces like a LED or a button, they have wire-ups and you can copy-paste the code. So it's a great way to get started. You often have to be tethered to a host unless you use something like a Raspberry Pi that might be able to run Node.js by itself. And there's certainly less examples in classic Arduino projects. So that means you sometimes have to figure it out a bit more. The third option is sort of untethered nodebuds, meaning we just run JavaScript straight on the microcontroller. One of the options is JerryScript. It's an ultra-lightweight JavaScript engine for the Internet of Things. That's what the website says. It runs on Samsung's IoT.js. And it is really lightweight, and it has a super small memory footprint, so this is great if you really try to run this in production, because you can use really cheap microcontrollers. But not every JavaScript feature is available, and then also it's not really beginner-friendly from the website, because it still shows a bunch of C++ code, even though you're on the JavaScript website. So it's not the best thing if you're not familiar with that ecosystem. Another option is Esprino, is a JavaScript interpreter that comes with its own hardware, but you can also run it on the ESP8266, which is, again, the microcontroller that costs $3. And it has its own hardware, as I mentioned. It's completely open source and open hardware, which means if you want to manufacture your own, you could. And it comes with its own IDE, and because it's not actually Node running, it doesn't support the entire NPM ecosystem, and it's not compatible with Johnny 5. A few years ago, if you've been to JSConf EU, there was this company called Neonius that gave out a bunch of free devices to push their Indiegogo. You can buy these now. I still haven't built anything with it, but they also allow you to run on ESP32, which is the new version of like the ESP8266. Again, it comes with its own IDE, but it comes with TypeScript out of the box, and they basically built a compatible runtime to Node, which means you should be able to use all NPM packages, and it has built-in Ethernet and Wi-Fi, so that's great. One of the things I'm excited about is the Tessel 2, and that's the Tessel 2 itself. It has a lot of useful components. It has USB, it has Ethernet, and a bunch of other things. But the cool thing is it actually runs Node.js, and that means you can run almost the entire ecosystem because it runs on a Linux fork. It can't run some native dependencies, but in theory it can run most, and it's compatible with Johnny 5. So you can again use your own tool chain. It's a bit more pricey because it's fully open source and open hardware, meaning there's no business behind it making money. It's just the community working on that. And one of the things I built with that was I hacked a coffee machine with it. And I call this project CascadiaJS, where the goal was that I wanted to learn how to control an existing device. And I wanted to build an API because I work at Twilio and everything we do is API. So I was like, why doesn't this have an API? And so I wanted to build an API that implements IETF RFC 2324. And you're like, Dom, what's that? That's the HTC PCP, and if that still doesn't ring a bell, that's the Hypertext Coffee Pot Control Protocol. That was proposed on April 1st, 1998. That's where the status code I'm a teapot comes from, because the protocol suggests that if you're talking to a teapot instead of a coffee pot, it should reply with 418. So why did I use a Tessel for that? One, the coffee machine should be untethered. It was my flatmate's coffee machine, and I'm fairly certain he would have not been happy if every time he wanted to brew a coffee, he had to connect a computer first and run a script. I wanted to use Johnny 5 so that I could swap out hardware over time, because I mentioned the Tessel costs, I think, $40 or something, and like I don't want to use that for every single, like I don't want to get like a bunch of them, so I wanted to be able to swap it out. It had to be internet connected, and the Tesla had 2 ways to do that, and it should be quick and easy to set up. I didn't want to bother installing Linux on a Raspberry Pi, and they just come with a CLI that you can say like, run this JavaScript file on the machine. So as for hacking, I'm going to rush through this because I have a blog post, but I still want to give you a quick idea. That was the coffee machine we had, and we did, again, the same approach that we did with a Porg. We just opened it up and looked at what was in there. And so this is the side view of the coffee machine. It's a bit dark, but essentially there was in this corner, there were like 3 things that were interesting. One of them was the microcontroller, one of them was the buttons that you would interact with, and what I labeled the interesting cable. And the reason why it was interesting is because you could plug it out. It wasn't soldered on, which meant that we could plug it out, we could take out the buttons and look at them. And so we plugged in that cable and tried to figure out like how it was set up, and we drew diagrams, and then we cleaned up the diagrams because it was 4 a.m. on a Friday night, and we figured we should, like, maybe we're looking at this wrong. But ultimately, we went a very similar route to the Porg one, except that we went bigger. So instead of using an Opto Coupler, what we did is we used these things called relays that basically can simulate button presses programmatically, and we just replaced the actual buttons with those things. So that's how the wire up went, but essentially relays are these things that click. And so that's how you can use that. There's an entire write-up of how I approach this. That is way longer, so if you want to get into depth, because I've rushed through that, feel free to check that out. On the pros and cons, you can run untethered systems with JavaScript. That's pretty awesome, meaning you can use your familiar language, and potentially the entire NPM ecosystem. But you're less flexible in hardware choices. There's only a few, and you're missing cutting-edge features of the language. And some docs are better than others. So how can you get started? One thing I recommend is find a project you want to do rather than trying to learn everything first. Because I think use case-driven learning is much more useful and much more effective for your time. Try to hack existing things. So, take something that you're fine with breaking, but would be fun to play around with. And one thing you should learn is a few electronics basics. And really what I'm meaning with that is if you don't know what amp, volts, and ohm are, try to figure out that and how they play together. And then a few things that are useful to have around is a digital multimeter to actually measure what amps, volts, and ohm are. A breadboard, which is a white thing that I showed you where you can use jumper wires to set up a circuit without having to solder. A few resistors and LEDs and those solid-state relays to simulate button presses. And there's a few starter kits. There's a Johnny 5 Inventors kit that contains a Tessel. There's these things called growth starter kits, which if you don't want to worry about plugging in the right things, they have like fixed plugs that only go one way, so that's great for beginners, but you're bound into their ecosystem. Or you can just get a generic Arduino starter kit from your favorite shop website. There's a few resources that I'll be tweeting out afterwards as well, so you can check them out again. And with that, thank you everyone so much for your attention, and have a great rest of the day.